Hi, this is Mrs. Clark and welcome to my video on steps to create a box plot. So we're going to be creating a box plot together today. We'll go through these steps with an example of how to calculate everything you need to calculate, how to draw your box plot from what you've calculated, how to interpret what it is that we're calculating. So the first thing you're going to want to do is make sure that you have these three things. So steps to creating a box plot, the first part and second part of creating a box plot, so these get cut in half. I'm going to just read a couple things through this steps part first, but we're going to be following these steps as we go, and I'll be explaining each piece as we go, so make sure you write down what makes sense for you in these situations. So first thing when creating a box plot, it's called a box plot for short, but the longer name is a box and whiskers plot, so I will show you why that is once we get to drawing it. But the first thing is to make sure that your data is in order from least to greatest. So if I look at my data, this is the same tomato plant data that we had in our histogram notes, where we were looking at the number of days it took a tomato plant to produce tomatoes. I took the same data, it was in a little table before, but now I put it in a list. And I actually created the list with the smallest numbers first, and then they get bigger as you go through, from 47 through 90. So I already did number one for you, I put them in order. If your data set is not in order, make sure you put them in order before you start. Because the next thing we're going to need to do is calculate what's called the 5-number summary. So the 5-number summary consists of 5 different calculations that we need from the data set in order to make a box plot. So the 5-number summary consists of the minimum, which is the smallest number in your data set, the maximum, which is the largest number in your data set, the median, which is the middle number in your data set, and there's instructions on what to do here, and then your Q1, which is called your first quartile, and your Q3, which is called your third quartile. So we're going to talk about how do we calculate each of those things, because once I have those 5 calculations, then I can make a box plot. So let's get started with that part first. The directions on how to actually draw the box plot are here after that, and so we'll be following those after we finish. So first, creating the box plot, we need to start figuring out the numbers in the 5-number summary here. So we need our minimum of our data set. Since it's already in order, our minimum is the lowest number, which is 47, so I'm going to fill that in. And then our maximum is 90, which is the biggest number, so I'm going to fill that in. So I already have 2 of my 5 numbers. We've got to find this 5-number summary first. So after that, the next thing to do is to find the median. So the median is the middle number. So you'll notice here it says, if there are 2, find the average of them, and draw a line where the median is to divide the data set into 2. Well, if we look at the data set, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 numbers. So our median divides the data set into 2 equal groups. So if we have 30 and we want to divide that into 2 equal groups, we're going to make 2 groups of 15. So what our median is going to do is figure out what is between those 2 groups. So if we take a look at this data set of 30 numbers, the first 15 will be in the first group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right here divides the group. So below that line is the first 15, and after that line is the second 15. So our middle is between the number 70 and 72. So in order to find the number between them, sometimes you can just know what it is by looking at the numbers. Like if you think about the number between 70 and 72, you can probably guess that it's 71. If I didn't know what the number was that was between them, what I would do is I would average them. So I would take 70 and add it to 72, and then I would divide the answer by 2 because there's 2 numbers that I'm adding together. So 142 divided by 2 equals 71. So the number that is the median number is 71 because it's between 70 and 72. So my median is 71. What does that mean in reference to this data? Like, what does it represent for the data? Well, since our data is about number of days, this is 71 days. And since it's talking about tomato plants, it's talking about the middle number of days that it takes tomato plants to produce tomatoes. So I know that half the tomato plants produced tomatoes before these days, and the other half produced it after these days, since this is the middle. So the way I'm going to write that is I'm going to say half of the tomato plants produced tomatoes before 71 days, and the other half after 71 days. So it shows that I really understand what the 71 is representing, that half of my plants happened before that, the other half of the plants had happened after that. So right here we're actually doing two criteria at the same time. Criterion A is like, do you know and understand how to calculate a median, which is this piece up here, getting the 71. But criterion D is applying math to real life, so it's taking the 71 and making sense of it. What does it have to do with the tomato plants? So we're practicing for criterion A, which is knowing how to make it or how to calculate it, and then criterion D is knowing how to interpret it. All right, the next step is to try to find our Q1, which is our first quartile. So if you think of it, the word quartile sounds like quarter, or like 1/4. So what quartiles do is they split your data up into 4 equal groups. Right now we have our data split into 2 equal groups, because we know this line divides it into 2 equal groups. Now we're going to take everything before the line and we're going to split that in half so I can figure out where the quarter is. So if you think about it as like school related, we're looking at basically where a Q1 marking period would be. So if I look at all of this data, 47 up to 70, I need to find the middle of those numbers. So I'm going to actually rewrite all of those numbers down here. 47, 52, 53. I want them in a big long line because I want to show you a way to find the one that's in the middle. 55, 57, 60, 61, 62, 63. I got 65, 65, 65, 65, 68, and I'm going to squeeze in the 70 here. Okay. So I need to find the middle of this so I can divide it in half. But this is 15 numbers. It's not an even number where I can just split it evenly, quickly into 2 groups. I'm going to need to think about how can I find the middle? And so you may have done this way before when you learned finding a median, like in middle school at some point, is you may want to just kind of like knock off a number, a low number and a high number, kind of in pairs, until we find the one that's in the middle. So I'm going to pair them off. 47 with 70, 52 with 68, 53 with 65, 55 with another 65, 57 with another 65, 60 with another 65. And I'm just kind of doing a low and a high and a low and a high, and then when I get to the middle, I have one left that doesn't pair up, and that's going to be my Q1. So 62 is my Q1. And this is a marker that says basically where is the first quarter of the data. So if you think about quarters in your marking periods, at Q1 you're 25% of the way through your school year. So where your Q1 is in your data, that tells you where the first 25% of your data ends. So it's kind of like a cutoff point to say, like, before this is the first 25% of the data. So we know that 25%, or if you want to say a quarter, because we said half up here, of the plants produce tomatoes before 62 days. Also, that means that the other 3 quarters are on the other side of it, so there's a quarter here plus all the other ones that are up here that we didn't count. So 75% of the plants produce it after 62 days. And so a box plot divides our data by quarters instead of in intervals like a histogram. So we get to see, like, where is each quarter of the data, and we can kind of lump them together in different ways to look at the data together. So our next step is going to be to find the Q3, which is going to be almost exactly the same thing, but we're going to use the numbers after the 71. So we're going to use 72 all the way up to 90, and we're going to do that here on question 3. So I'm going to list out the data from 72, 72, 75, 75, 75, all the way up to 90. And do the same thing here to find our Q3. That will be the last part of our 5-number summary that we need so we can make our box plot. And I like to write all the numbers over again so that I can do that, knocking off one from each side to find the middle. So when I go to find the Q3 or the third quartile, I'm just going to mark them off like I did before, one on each end, a pair at a time, until I find the one that's in the middle by itself. So 78 is the one that's by itself, so that's our Q3. So let me add that over here. So that means that 25% of the data is after 78 days. So that means 25% of the plants produce tomatoes after 78 days. So now that I have my 5-number summary done, the next step is to make the actual box plot. So if you want to follow the directions, they're here. I'm going to just go through them with you. So first thing we got to do is we got to number our number line here so that it fits our data. We're going to have to show these 5 things on the box plot. That's how a box plot is built, with those 5 numbers. So I need to be able to show my 47, I need to be able to show my 90, and I need to count evenly along the scale. So if I go 47, 48, 49, 50, I'm not going to fit them all. I could go 47, 49, 51, and go every 2 if that would work. I want to find a number that works. There's lots of choices. We need to make sure that we're low enough to get 47, so maybe we start at like 45. And if we count by 5s, we should be able to get to 90. So 45, 50, 55, 60, all the way up to 90. I believe we can fit up to 95 here. And that's okay that we go a little higher than we need. We just need to make sure that we can display the numbers. So I can display 47 even though it's not a number on my number line. You could have started with 47 if you wanted and counted every 5, like 52, 57 if it doesn't bother you to have like odd numbers like that. But the first thing that we do is we graph our minimum and our maximum. So we make a dot where 47 is, we make a dot where 90 is. So 47 is approximately halfway between here, so I'm going to go like above the middle, up here, and I'm going to make a dot. Your box plot is made above your number line. I'm going to do the same thing for 90, try to make them even, going like horizontally. And that marks the beginning and the end of my box plot. Then I have to make the box part. The box part is made going from Q1 to Q3. So I'm going to go from 62 to 78. So 62 is about here. I'm going to start my box. 78 is about here. I'm going to end my box. And then I'm going to connect them in between. Mine's a little bit off kilter here, but that's okay. And then my median is just I get a line down the box wherever 71 is. So 71 is about here. So my line is about there. Notice it's not evenly in the middle. That's okay. This side of the box is a little smaller than that side. That's fine. We just have to make sure we're marking off where they go. And then you connect your dot to the edge of your box on both sides, and those are called your whiskers. So that's why it's called a box and whiskers plot. Mine was not really even, which is why my whiskers end up being crooked on this side, but that's okay. I want you to also mark in your notes here just what each of these things represented so we remember how we got it. This was our min. This was our Q1, this was our median, this was our Q3, and this was our max. So when you're reading a box plot, that's where you get those numbers from. You can read them off of the box plot. When you're making a box plot, you don't need to label them like that. You just need to make sure you put them in the right spot. So the last 2 pieces of information that you can get from a box plot are the range and the interquartile range. So the range is looking at the maximum value and the minimum value and subtracting them. It's saying how far apart are all of your data values. So the range for this data would be 90 minus 47, because that's my max minus my min, which is 43. So the data is spread apart by 43 days. The interquartile range, or the IQR, is the range from one quartile to another. So it's your Q3 minus your Q1. So the IQR is what we almost always call it, would be Q3, which is 78, minus Q1, which is 62. So that is 16 days. So my box is spread apart by 16 days. All of the data is spread apart by 43 days. So go ahead and glue that in your notebook. Let me know if you have any questions, and then we'll get started on some practice on reading and creating these on our own. Thanks for watching.